Picasso, it is my name. I'm here for Mathematics Senior 2. We are looking at algebraic explosions, factorization and expansion. Today I want us to look at the application of factorization method. We have an example here. We have an example. Solve for n. Solve for n. Number 1 is 1, 2, 3. That's n. This is equivalent to 83 base 10. The question is solve for n. We shall first express 1, 2, 3 base 10 in terms of base 10. Let us expand. We have 1 times n plus 2 times n plus 3 times n. This is equivalent to 83. We shall give powers here. Remember, when we are giving powers, the power should be on n. Start off with a 0, then decide 1, then here we have 2. 1 times n squared, it gives the n squared plus 2n, because n to power 1 is the same as 1 plus 3. Remember, the number to power 0 is the same as 1. So we have multiplied the 3 by 1, which gives the 3. So here we have 83. Now when you look at this expression, it qualifies to be a quadratic equation, whereby we can rearrange it: n squared plus 2n plus 3 minus 83 to give a 0. For this case, our n squared plus 2n minus 80 to give a 0. It is a quadratic equation. I want us to use factorization method to find a value of n, of which we are supposed to identify the sum. Our sum is 2. So this is 2. Then the product, it is negative 80. Dear learners, our product, it is negative 80, but not positive 80. Should you say positive 80 to give no correct answer? We need to identify the common factor, and then two numbers. When you multiply, they'll give us negative 80. When you add, they'll give us positive 2. So we check in factors of negative 80. I can see a 10 and 8, of which 8 is supposed to be negative, such that when you add, it gives a 2. And when you multiply, it gives a negative 80. So here, our common factor, it is 10 negative 8. 10 negative 8. Let us substitute this. Where did this 2 end? We shall have n squared plus 10n minus 8n minus 80 equal to 0. Now we shall look at the first two numbers. Look at these first two numbers. There is a common factor, and that common factor is n. So this is n into, divided by n, it gives the n. Even here we divide by n, it gives the positive 10. Now we shall look at these two numbers. There is also a common factor, which is negative 8. So we have minus 8 into, divide by negative 8, gives the positive n. Divide by negative 8, gives the positive 10. But the outcome should be 0. Let us observe. Try to observe. There is something common. There is something common, and that is 10. n plus 10. n plus 10 is the common factor. So we are going to pull out negative 10 plus. We are going to pull out to n plus 10. We cover that. There is a balance of n. We also cover this. we have 8. Okay? So we shall conclude that for either n plus 10 equal to 0 or n minus equal to 0. So n is negative 10 or positive 8. We are dealing with the bases. Remember, we don't have a negative base. So we should not consider this as to be our final answer. Let us draw a conclusion. Therefore, n equal to 8. Or we can say n is base 8. So this is our value of n. Allow me to look at the second number. That is number 2. Whereby we have 1, 2, 3, base n. This one gives the 38, base 10. But the question was solve for n. Solve for n. Let us carry out the same procedure as in Roman number 1. This is 1 times n plus 2 times n plus 3 times n. The answer should be 38. We have a uniform base, that is base 10. But let us give the powers. We give the powers. So this is the n squared plus 2n plus 3. Remember, any number power 0 is 1. 1 times 3 gives a 3. And this is equivalent to 38. It's equivalent to 38. Rearrange the expression. Plus 2n plus 3 minus 38 gives a 0. So here we shall say n squared plus 2n minus 35. It gives a 0. But the question was solve for n. Let us identify the sum. Let us identify the sum. Our sum is 2. Plus the product is negative 35. Common factors. We check within the factors of negative 35. We check within the factors of negative 35. I can say 7 and 5. I can say 7 and 5. But when you add, it does not give a 2. So we need to modify. So this 5 should be negative. When you add this, it will give positive 2. When you multiply, it will give negative 35. So we are going to substitute this in this expression. N squared plus 2n minus 35 equal to 0. So we have the common factors as 7 and negative 5. We shall substitute it. It gives the n squared plus 7n minus 5n minus 35. This is 0. We factorize. Here there is something common. Factorize the common factor, that is n. So we have n into n plus 7. So here there is negative 5, is the common factor. Negative 5 into, when you divide by negative 5, it gives the n. Divide by negative 5, it gives the positive 7. This is 0. So we shall identify common factors still. That is n plus 7. We cover, the balance is n. We also cover, because we are factorizing it out, it gives a negative 5. This is 0. For either, this bracket is 0, that is n plus 7 is 0, or n minus 5 is 0. we shall say that n equal to negative 7 or positive 5. Or positive 5. Remember, we don't have a negative base. So, allow me to draw a conclusion. Therefore, n equal to positive 5. N equal to positive 5. Give another example here. 1, 1, 3. Base n, this is 90. This is 93. Base 10. The question was solve for n. So let us first expand. This is 1 times n plus 1 times n plus 3 times n. This is equivalent to 93. Give powers. Give powers. Give powers. So that one gives the n squared plus n plus 3. This is 90. 93. We correct like terms. This one cross to the side. That is n squared plus n plus 3 minus 93 equal to 0. So for this case, we have n squared plus n minus 90 equal to 0. Our sum, because we are using factorization methods. So let us say sum. The coefficient here is 1. That is our sum. Plus the product, it is negative 90. The product is negative 90. Common factors, we check within 90. Factors of 90, I can see 9 and 10. But one of the factors should be a negative. Such that when you add it, it gives a 1. So we have negative 9 and positive 10. When you add these two, they are supposed to give you 1. When you multiply, it also gives a 90. So this one qualifies to be a common factor. Say n squared minus 90n plus 10n minus 90. This is a 0. I'll look at the two numbers here. We have n, it is common. When you divide by n, it gives the n. Divide by n, it gives the 9. So here, there is 10 as our common factor. This is n minus c, gives a 0. Something common, that is 9x, n minus 9. It's also common here, so we put it out. N minus 9. So here, when you cover that, the balance is n. You also cover this, the balance is 10. For either n minus 9 is 0 or n plus 10 is 0. We say that n equal to 9 or n equal to negative 10. We don't have a negative base, that's why we need to do a conclusion. Therefore, n equal to 9. Or we can say n is base 9. N is base 9. I want to give a trial here. I want to give a trial, or allow me to give an activity here which should be done. Allow me to give an activity here which should be done. Yes, this is what we have. We say that is solve for n. Solve for n. Number 1, 2, 3. It will be 1, 2, 5, base n. It gives the 85, base 10. Next, 1, 4, 5, base n. This one gives the 65, base 10. Next, Next, we have 152 base 10. This one gives you 72 base 10. Next, we have 154 base 10. This one gives you 74 base 10. We can have the answers here. Try to compare with these answers. We have 8. We also have 6. We also have 7. We have 7. So these are the possible answers. Try to check on yourself after trying out this. We say that the identity states that a minus b into a plus b, it gives a squared minus b squared. This is what we call difference of two squares. We can have an example here. Factorize the following. Factorize the following completely. Factorize the following completely. Roman number 1. We have x squared minus y squared. Once you observe this, it's similar to this one. So our answer is going to be x minus y, then x plus y. We apply the difference of two squares. Let us look at case 2, whereby we have 2x squared minus 18. They want us to factorize completely, but when you observe here, there is a common factor, that is 2. When you divide by 2, it gives you x squared. Divided by 2, it gives you 9. And when you observe, 9 is a square number. So try to identify that square number. Which number do you square to obtain 9? And that is a 3. So here we have x squared minus 3 squared. But this is not the final answer. We are supposed to apply difference of two squares, of which our final answer is 2 into x minus 3. Then x plus 3. This is our answer. We can also have number 3, and that is 3x squared minus 75 y squared. Like that. There is a common factor when you observe, and that is 3. So you have 3 into x squared. When you divide 7 by 3, it gives a 2, remainder 1. That is 15. 15 divided by 3, it is a 5, y squared. But we cannot say that that is the answer. Should you stop at this level, you'll be getting 1 mark. Go ahead to apply difference of two squares, of which we know the square root of 25. That is 5. We know also the square root of y squared. That is y. shall put them in that bracket. All in all, we are targeting at application of difference of two squares. So the answer is 3 into x minus 5y, then x plus 5y, like that. So this is our final answer. Let us look at Roman number 3. Let us look at Roman number 3. Yeah, for this case I have to give very many examples because it looks to be a challenging part. The application of this, you may consider this one to be a positive, but it is a negative. So we have a b cubed c minus a cubed b c. They want us to factorize. When you observe properly, there is a common factor that is a, b, c. That one is common. Let me say there is a sc. I can see sc. Let us begin with the a. Meaning that we have b cubed c minus s squared b c. Like that. But that is not the final answer. Go ahead to identify. I can see there is b and c. Meaning that I have a b c into, when you divide by b, it will give b squared. Divide by c, c to go. Here, we are dividing by bc, and we have minus s squared. In that arrangement, but that one cannot be the final answer. Allow me to apply difference of two squares. This is fbc into b minus a, then b plus a. So this is our final answer. Lastly, allow me to talk about this. We have p squared. Let it be p to power 4 minus 1. Yes, that is what we have. But we are supposed to apply difference of two squares. We can modify it in the form of, this is p squared, squared again. Remember, 1 can be to power 100 or power million, power 0 still to remain a 1. So allow me to say this is 1 squared again. Yes. We modify it again. This is the p by applying difference of two squares. This is p squared minus 1 squared. Then p squared plus 1 squared. In that form, we cannot draw a conclusion that this is the answer. I can set difference of two squares here. So we have p minus 1, then p plus 1. Also, we have p squared plus 1. So this is our answer. That is our answer. That is our answer. Let us look at our child here. Let us look at our child. Factorize the following. Factorize the following completely. Number 1, we have x squared minus 1. Number 2, we have x squared minus 100. Next, we have 2x squared minus 50. Next, we have 5p squared minus 80. So try out at work during your free time. Let us have another example here. Example. It also calls for application of difference of two squares. Application of difference of two squares. Simplify the following. Simplify the following as far as possible. Simplify the following as far as possible. We have x squared minus y squared over x plus y. I want us to simplify that. But we always have this one calls for difference of two squares, of which we have already seen it that it is x minus y, then also x plus y over x plus y. We can only leave it in that form. Where possible, cross out the common figures, like this one and that. So our answer is x minus y. Next, we have this. We have 2s squared minus 2b squared over 4a plus 4b. Yes, we can factorize it out, of which here there is a common 2. We factorize it out, that is 2 into s squared minus b squared. In that arrangement, divided by, here you can see there is a 4. This is the 4 into a plus b. Let us look at this. It calls for application of difference of two squares, of which this is 2 into a minus b, then a plus b, all over 4 into a plus b. We can reduce. I can see this one goes with it. That. Here, by 2, 1. By 2, 2. So the answer is a half into a minus b. That arrangement. Next, we can have this. We can have this. Number 3. We have 7.5 squared minus 2.5 squared. We simplify as far as possible. The master says also without using tables or calculator, if you find a question of that form, so here, application of difference of two squares, minus 2.5, then is 7.5 plus 2.5. In that arrangement, 5 minus 5 gives a 0. 7 minus 2 gives a 5. Then here we add 5 plus 5, that is a 0, carry 1. This is 8 plus 2 gives a 10. Let us simplify further. We have 5 into 10. This one gives a 15. So this is our answer. Good. are saying that solve for x and y such that solve for x and y such that x squared minus y squared, this one gives it 12, and the x plus y, this one gives a 6. And they want us to solve for x and y. But when you observe here, there is difference of two squares. That is the first case to identify. So we shall say solution. We have x squared minus y squared equal to 12. When I observe, you can see x minus y, then x plus y. This is 12. You can say equation 1. Next, we have x plus y equal to 6, equation 2. For this case, allow me to divide equation 1 by 2. I'll say that from equation 1 divided by equation 2. Divide by equation 2, of which in equation 1 we have x minus y, and also x plus y, and that is equivalent to 12. Okay? Then in equation 1 we have x plus y. Whereas here there is 6. We are supposed to reduce or to simplify. Before we proceed, we see that this one goes with that. Meaning that we have x minus, this is equivalent to, when we divide by 6, it gives a 2. So we have equation 3. We have equation 3. When you look at equation 3 and equation 2, we have different signs. So I'll say add 2 and 3. Because of different signs, let us add to eliminate y. However, you may also use graphical method, substitution, matrix. If you have covered the matrix, you can also try it out. Then you compare your answers. We say the 2, that is the plus 3x. This is 2, 3. We add. When you add, we shall eliminate y. And this one gives it positive 2x equal to positive 8. But our interest was to solve for x. I have 2x equal to divided by 2, x equal to 4. So when you divide the x value to be 4, we don't have the y value. Let us get the y value. We substitute x into, we have 3 equations. Pick any of your choice. But I prefer equation 2. When I say equation 2, that is x plus y equal to 6 when x is 4. So this is 4 plus y equal to 6. What is the y value? Let us make y the subject. So this is 4 minus 4 plus y equal to 6 minus 4, y equal to 2, and x equal to, we know x value, it is 4. back to the equation. Solve for x and y. And allow me to give another example similar to that. Aloma number 2 is here. We have x squared minus y squared. This one gives the 32. And the x minus y, it gives the 8. We are supposed to solve for x and y, but we see that it goes for application of difference of two squares, whereby x squared minus y squared, it is x minus y into x plus y equal to 32, equation 1. We have x minus y equal to 8, equation 2. We shall use for the same procedure, we divide. Allow me to say from equation 1 divided by equation 2. We have x minus y, also x plus y equal to 32. By x minus y, even here, like that. We can reduce. Because of a common factor, we can reduce. This one goes with that. We remain with the x plus y equal to, when you reduce it here, you may say by 2, or by 4, or you can say by 8, it gives a 4. By 8, it gives a 1. So this is equation 3. Our interest was to solve for x and y. Our dear learners, let us go ahead to find x and y. Let us go ahead to find x and y. Let us go ahead to find x and y. I'm comparing equation 2 and 3. I'll add. Allow me to say from 3 plus 2. You need 2, we have x. This is 8. In 3 we have x plus. This is 4. We add. When you add, we shall have 2x equal to 12. Divide by 2, divide by 2. So the x value is 6. Our x value is 6. But we are interested in the y value also. Let us find the y. Let us find the y. Let me substitute x into equation. We shall look at is 2. Allow me to look at equation 3. It is well 7.5. You may use this one, but I know majority of you fear the negatives. So go with this one, which is with a plus. So we have x plus y equal to 4 when x is 6. For my case, I have 6 minus. This is 4 minus. What is y? Y equal to negative 2. And the x equal to positive 6. I want you to notice it is not a must that every time you are supposed to come up with the positive values only. You can get a negative. You can get a decimal or a fraction. You can get a decimal or a fraction. Without wasting time, allow me to give you an activity here. Solve for x and the y. Solve for x and the y. Solve for x and the y. We have x squared minus c y squared. This one gives the 32 and the x plus y. This one gives the 16. My number 2, this is 1. My number 2, we have x squared minus y squared, this is 72. And the x plus y, 36. Next, x squared minus y squared. This is supposed to be 48. And the x plus y, it gives us 16. Lastly, but not least, that is number 2. Factorize completely. We have a squared minus b squared. Hence evaluate. We have 8.5 squared minus 1.5 squared. That one makes it 4 marks. We can also look at this. If A operation B is a squared minus b squared over a plus b, evaluate. We have 7 operation 5. From number 2, it is 3 operation 7 operation 5. Dear learners, when you observe here, it calls for application of difference of two squares. First simplify. When you simplify this, it will give A minus B. So I use A minus B here, of which the answer here it is 2. And also the answer here it is 1. Then back to this, apply difference of two squares. Apply difference of two squares. Allow me to stop here. We shall start off next time. Our next topic is going to be statistics. Thank you for being part of this session. Remember to sanitize, wash your hand,